Horizon, and another one is Canva. I'll post the ebooks, the PDFs on the Google Classroom today. You can go through the content and see the contents, whatever the guidance. So I'll be posting the content. Anything else you want to ask me? Anyone, any questions?
Ma'am, your voice is quite low.
मैम
Ma'am,
आपकी
your
वॉइस
voice is
बहुत
quite
लो आ
low.
रही है.
Okay. Is that fine now?
Yes, ma'am.
Okay.
Yes, ma'am.
So this is the first unit we are starting with the introduction of networks. Any technical problems, you just let me know. You make me stop there, and I'll stop and I'll rectify the problem. Okay.
Okay.
So let's start with data communications. What is a data communication? What is data communication? Anyone who can tell?
Exchange of data between devices.
And what is the data?
Exchange of data between devices.
Yeah, what is data?
One
I
piece
mean,
of
data
information
is a collection of raw facts and figures.
Anything you want to transfer from one side to the other side, from sender to the receiver, that is a message. It can be a normal text message, it can be audio, it can be video, and it can be anything else, PDF also. So that is that is data. So data communication, it includes the sharing of information, and when we share face to face, that is a local communication between the two parties, and telecommunication is long distance communication between the two parties. So the telecommunication, it includes telephony, telegraphy, television, and it means the long distance communication, as I told you. So word data refers to information presented in whatever form is agreed upon by the parties creating and using the data. So suppose I say I want to send some selfie or maybe a pic of myself to you. That is an information. That is the data. If I just sent my Google Meet link to you, that is also information and data. So that is the agreed upon form by the two parties, the sender and receiver. So whenever I send you the link, Meet link, that will be treated as a data or information. So the data communication is the exchange of data between two devices via some form of transmission medium, such as wire cable. Now, as I sent you this Google Meet link or any message, when I'm sending it to you, that is data communication. I'm communicating the data and information to all of you, and that is known as telecommunication, because I'm not sharing it face to face. I'm sending it from a long distance to all of you. So that is data communication. So in data communication, we have to first see the data communicated between the two parties, the sender and the receiver. It should have some effectiveness. And there are 4 fundamental characteristics for data communication effectiveness. First is delivery, then accuracy, timeliness, and jitter. Is my screen visible to all of you?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. So the first one is delivery. So the system must deliver the data to the correct destination. Now, if I want to send the data to only computer science 3rd semester, but I wrongly sent it to some other address, like some other 1st semester class, or maybe the 5th semester, or maybe some other stream, 3rd semester of other stream, then it will be wrong data delivery. So the data should always be delivered to the correct destination. It should be the responsibility of the entire data communication system that the data should be delivered to the correct device, and it should only be read by and processed by the intended user or the device. Then the next characteristic of a data communication system is accuracy. So the data must be delivered accurately. Suppose I typed in some other information, but it is not accurate and it has been changed while communicating it to the other party. Maybe the system has changed it, the software has changed it, or hardware has changed it. So the correct information has not been delivered accurately to the destination. So if the incorrect data or information has been transferred to the other side inaccurately, then it is known as unusable information. Suppose I want to send image file, and I just want to tell you the account on which you have to do Paytm, and I'm sending you the pic of my account ID, or I just want to send you the email address. Then that email address, if I'm just clicking on the pic, if it is written on a paper and it is not legible, you may not be able to read it clearly. The image is not readable, or it is not clear. Then in that case, the data may not be accurate. It is not usable. So you are not able to send me the email, or the fee will not be transferred to the accurate account. So that is data accuracy. Then timeliness. Suppose I send you the information about my class, and the data will not be delivered because of the telecommunication system or the data communication system. It is delivered late. Suppose I sent my data and my LAN is slow or my network is slow, and I told you to join my class or some meeting within 5 minutes of sending the link. And that link is sent or received by you after the entry time is over, maybe 5 minutes or 10 minutes. Then it's useless. So data in a data communication system should be delivered in a timely manner. So data delivered late or inaccurate will be useless. Then jitter. It refers to the variation in the packet arrival time. If the uneven delay is in the delivery of audio or video packets, for example, let us assume that video packets are sent every 30 milliseconds. If some of the packets arrive in 30 milliseconds delay and others are delivered in 40 milliseconds delay, then uneven quality in the video is the result. Now you must have seen that if you're watching a video on HD quality video, then it has a great impact and you are interested in watching it on a LED device or LCD device. But if you are watching it through YouTube or internet, due to your internet connection or maybe your device speed, maybe your device is 3G or 4G device, if you're watching on a mobile or maybe on an old laptop, then the video may be loaded on an uneven basis. Some frame is loaded in a 30 milliseconds delay. Some due to the network connection, the other part of the video is delivered and displayed on your laptop or mobile in 40 milliseconds delay. Then it will be the end user will be uninterested in watching the video because you will not find it interesting, because the video will have more delay. So one frame or one scene of a movie will be delivered properly, and another scene it is giving you delay. Then you will get bored after some time. So data communication systems should ensure, a good data communication system should ensure the four characteristics, fundamental characteristics. One is the data should be delivered to the correct destination. Accuracy, the data should be delivered accurately. And then timeliness, it should be delivered on time. And jitter, there should be less jitter, so that the user doesn't get bored. There are 5 components of data communication system, as you can see here in the pic. There are 5 components. First is the message which you want to send to the user. So message is the information that is to be communicated. So popular forms of information include text. I'm sending you some text message or some numbers. Maybe suppose I'm telling you what is your internal assessment, what is your attendance. Then pictures, if I'm sending some pictures, audio and video. So these are all kinds of messages the sender want to send to the receiver. Then the sender in the data communication is a device that sends the data message. It can be a computer, workstation, telephone handset, video camera, and so on. Or it may be a mobile device also in today's scenario. Receiver is also same. It can be computer, workstation, telephone handset, television, and so on. Then the transmission medium. Transmission medium is the physical path by which a message travels from sender to receiver. Some examples of transmission media include twisted pair wire, coaxial cable, fiber optic cable, and radio wave. Now you must have seen the older telephone systems when you were a kid, maybe 4 or 5 years of age. You must have seen the landline numbers. Have you seen the landline telephones?
Yes, ma'am.
Yes, ma'am.
Yes,
You
ma'am.
must have seen the wires, and you must have seen the cable TV also.
Yes, ma'am.
So these were all the transmission medium through which you were transmitting the. You must have seen a red and yellow color of wire at your home in some of the electrical appliances, like maybe near the fan or maybe near the coolers also, if you have coolers at your home. So those were twisted pairs.
Yes,
The two wires, blue and red or red and yellow or green and red color wires, they're twisted in a helical shape or DNA shape. So these are twisted pair cables through which we transmit the data. Earlier in telephone systems, in the initial phases when the telephone systems were developed, we used to have twisted pair cabling and wiring. Then came coaxial cables. You must have seen a hard and a thick cable when we used to watch cable TV. You must have watched cable TV.
Yes, ma'am.
Yes, ma'am.
So that cable TV is basically that was connected through a coaxial cable. So it was a hard core outside. It was not a small cable. It was a thick cable. It was not a thin cable like twisted pair. And it was a round cable in which we had the hard copper wire inside that coaxial cable, which was connected to the television or the cable TV set. That was coaxial cable. And nowadays, you must be hearing the latest technology which is coming in this pandemic and online classes era. That is fiber optic cable. You must have heard about Geo fibers and ACT fiber nets and other fiber network providers. Most of you who are in Delhi, you must be having the fiber optical network connected at your home for attending the classes. And your parents must be having the fiber network at home for doing work from home. So that is fiber optic cable. And radio waves, like you are using in this mobile network, the wireless medium, that is radio waves. Then protocol. Like if I start talking in, maybe suppose French or German, so that you may not understand. So protocol data in communication system, you should have a set of rules, which is known as protocols to communicate between the sender and the receiver, between the communicating devices. So if I just, while delivering my lecture, if I just start talking in German or French, that won't be the protocol which is agreeable to all of you, or between the receiver and the sender, that is me, your receivers. So if I am, suppose being a French teacher in some school or being a German teacher in some school, that is understood. The protocol is the teacher is speaking German and French. But when we are talking in the computer science class or computer networks class, it is understood the protocol should be either the hybrid mode, English and Hindi, or maybe only English. So that is the set of protocols that governs the data communication. It represents an agreement between the communicating devices. Without a protocol, two devices may be connected but not communicating. So just a person speaking French can't be understood by a person who speaks only Japanese. So these are the 5 components of a data communication system. Then data representation. How the data which is to be transmitted through the transmission medium is represented in the computer networks or in computer technology. So information that is to be transmitted, that is the data which is to be transmitted, is text, numbers, images, audio, and video. Have you done computer architecture and digital electronics? Third semester students, have you studied architecture or digital electronics?
Yes, ma'am. We have studied computer architecture, but not digital electronics that much.
Okay. CS you have studied, so you must have studied the binary number system and binary representation.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, so I'll just go fast in this. So data representation for text is basically, it is represented as a bit pattern. You must have heard about ASCII code or Unicode. So nowadays, in our times when we were students, we used to study the ASCII code. That was a basic Latin code. So that was basically 8-bit code, and it used to have 127 characters, and starting from 0 to 127, the maximum, that is 128. So 8 bits can represent maximum 128 characters. So therefore, ASCII character code, that is American Standard Code for Information Interchange, it was used earlier in the maybe 2 decades or 3 decades ago. But nowadays we have 32 bits to represent a unique. Any text can be represented. Like I want to represent T. So in ASCII code, capital T was, I think, suppose capital A. It was, I think, 65. The number 65. ASCII code 65 for capital A. So similarly, we used to represent the text information using a bit pattern of 8 bits or 16 bits or 32 bits, depending on which code we are using. Similarly, numbers, you must have studied about the decimal number system, binary number system, octal number system, and hexadecimal number system. Have you studied that?
Yes, ma'am.
So numbers
Yes,
can be
ma'am.
represented and directly coded into any of these numbering systems, octal number system, hexadecimal, or binary number system. And similarly, the operations on the mathematical operations on these numbers can be done using the numbering system that you have already done. Images, they are represented by bit patterns. Suppose I want to represent black and white information or image, then you can say the black pixels will be represented by 0 and the white pixels will be represented by 1. So basically an image is a collection of points or known as pixels. Picture patterns. So pixels, it depends on the image resolution. Suppose now you're saying when you're buying a camera or a mobile phone, you say what is the resolution of your camera. When you're buying a mobile phone, you say it is 100 megapixel camera of the phone or 56 megapixel or 100 megapixel. What is that? What is that? Can anybody answer?
It's resolution power.
Yeah, that is the resolution power. How much information for a particular picture will be stored? How many pixels will be stored for storing that picture? How many pixels will be used? So that is image. That is how the images are represented using pixels. So suppose I am storing an image and it is divided into 1000 pixels or 10,000 pixels. So the entire information about the image, its color and everything, its resolution and its patterns, anything about the image will be stored in the pixels. And higher the number of pixels used to store an image, better is the representation and better is the quality of the picture. But when we are having a higher resolution and higher number of pixels to store an image, we have to have a higher memory. So suppose you have bought a mobile phone 2 years back, it is of 64 GB. Nowadays, it is not good enough to store all the pics you are taking uh, throughout your lifetime or whatever. You have to store because whenever you are buying a higher resolution camera mobile phone, you will be needing a higher end memory in that phone. So earlier we used to have 4 GB internal storage mobile phones, then came 8 GB, 16 GB, 32 GB, 64 GB, and nowadays we have 128 GB. Why? Because the quality cameras are improving, the number of pixels required for storing those images is increasing. So we need to have higher-end memory device to store those images. If we're storing colorful image, the image can be stored, represented using colors, and we can have any color scheme. RGB you must have studied till 10th or 12th, that blue. So normally, if you are having a normal resolution pic, you can allot for every pixel, and for storing the red color component of that pixel, you can have 8 bits. 8 bits each for every color. So if you're representing an image in RGB and every pixel is represented by the RGB combination of that pixel, then 8 bits for red color, 8 bits for green color, 8 bits for blue color. Or if you want to have more combinations of RGBs and finer resolution for the color, you can store R in 16 bits, G in 16 bits, and B in 16 bits. This is how an image is stored in the system, and it is represented by the system. Then either you use the RGB traditional method for representing the image, or another method is YCM. YCM is yellow, cyan, and magenta. So these are the two methods for storing the color of an image. Then audio. Audio is the recording or broadcasting of sound or music, and audio is by nature different from text, numbers, and images. So it is continuous, not discrete. So you have like MP3 and MP4, all those formats for storing the audio. And like text and images and numbers, once you have stored and converted the numbers, it is same, it is static. But audio is continuously changing, so you should have another format for storing the audio messages, sounds, and music. Video also, it is the recording or broadcasting of a picture or movie. Then data flow. Data flow can be in 3 forms: data from the sender to the receiver, or the communication between the 2 parties can have 3 types. First is simplex data flow, half duplex data flow, and full duplex data flow. Simplex data flow says when your data is always flowing in one direction, that is from the main server, mainframe, to the monitor. So when you're always accessing the data, you are not sending the data. Suppose like you must have heard about those pagers. Pager devices you have seen maybe in when you were small. Have you heard about pagers? Pager devices. What form of data flow was there in pagers? How many of you have heard about pagers?
Ma'am, is it the radio device?
Yeah. The device can be anything. For data flow to be simplex, half duplex, and full duplex, the transmission medium can be anything. It can be a wired medium or wireless medium. The only thing is in which direction the data is flowing. So when only you are suppose you must have seen in WhatsApp also today they have nowadays they have integrated mechanism in the, WhatsApp that if you are not administrator you cannot send the data. So when that type of communication is there, suppose I create a WhatsApp group in which only I can post the messages and the whole class cannot post any message, then that is simplex. The data is always flowing in one direction. So if that type of communication is there and the data is always flowing from one direction to the other direction, not in the reverse direction, then that is known as simplex communication or simplex data flow. Then half duplex is when you are sending the data in both the direction, the forward direction and the reverse direction also, from the sender to the receiver and from the receiver to the sender back. But they are not synchronized, not in the same time. Then it is known as half duplex. You must have seen some army people using those intercoms and those devices in which way they say, yes, over and out, and I am speaking. So first one person is speaking and it is communicating the data, like in military and defense services. One person is sending the data and other person is quiet. It is just receiving the data. Then when it is say over and out, it just sits quiet and then the other side sends the data, and when it says over and out, then the other person can speak. So this kind of a communication, when the data is transmitted only in one direction, either from sender to receiver or receiver to sender. At a moment, at any time, only one direction can send the data. That kind of a communication is known as half duplex communication. And like in telephone system and in like Google Meet, in mobile devices, nowadays when we are talking of the telecommunication, it is mostly full duplex. The data can be, while I am talking, you are listening, as well as you can also send the data, maybe audio or text message, whatever, you can send the data on the same medium, same connected medium. That is known as full duplex. So direction of data all the time is both the sides, this side also and this side also. Like in simplex communication, keyboards and traditional monitors, like this monitor is always receiving the data from the system. So from CPU, this monitor is getting the data which is to be displayed on the monitor. So always it is the direction of data flow is from CPU to the display device, that is monitor. So this is simplex communication. Keyboard can never have output data. Keyboard can always be used as input data. So when keyboard is connected to the CPU, the data always flows from keyboard to CPU. That is simplex communication. In half duplex, like walkie-talkies and citizen band radios, like I was talking about, then in that case, this is half duplex. So in half duplex, there is no need for communication both directions at the same time. So entire capacity of the channel can be utilized for each direction. So there is no channel contention, there is no conflict, and the entire bandwidth for data communication can be used by both the parties at a particular moment. In simplex mode also, the entire bandwidth can be used by the sender to send the data to the receiver. This is simplex. Then full duplex, both the stations can transmit and receive simultaneously. Full duplex mode is likely like a two-way street with traffic flowing in both the directions. So full duplex mode is basically when the data is transmitted in both the directions, but the channel bandwidth and the capacity is divided into between the two directions. So suppose my data rate is 128 Mbps. So 64 Mbps will be used by the sender to the receiver, and 64 Mbps capacity will be used by the other side. So the data rate will be half. So you can say a telephone line is an example of full duplex mode. Then networks. There are different types of networks while doing data communication. So what is a network? It is the interconnection of a set of devices capable of communication. In this definition, a device can be a host or an end system, because a host is also called an end system. And a host can be a large computer, desktop, laptop, workstation, cellular phone, or a security system. So host can be anything, any device which is connected to other devices. Nowadays, you must have heard about the 5G technology and the smart homes. Have you heard about smart homes?
Yes, ma'am.
Yes, ma'am.
Smart homes are basically when all the devices, your refrigerator, your security alarm, your doorbell or your door lock, and your almirahs, safes, basically your almirahs in which you are putting your documents, and everything is connected to the internet, to your telephone or your mobile device. So while you are away from home, you can have a smart and safe home, and whatever is going on in your home, you can watch it on your mobile using an app. So that is also a kind of network. So any type of device through which you are communicating the data and information and which is connected to other device, that is known as a network. So a connecting device can be a router, or it may be a switch, or it can be a modem. You must have seen when you were kids, you must have seen a modem installed at your home, and you must have seen those big monitors like televisions, the wider ones, not TFT screens, not LED screens, but the bigger ones like Samsung TVs and older TVs, like a whole box cube. Those desktops were connected to the modem. Modem is modulator, demodulator. You must have done it in CSA. So modem can be a connecting device which is connecting the two communicating devices, that is the sender, the receiver, or the two telephones, or the two desktops, or two laptops, or it may be a switch or a router. Have you ever been to the college lab?
No, ma'am.
Okay, you must have seen. Okay, when you will visit the college, you will see, or you can see on the internet also, there are large switches in the organizations which have LANs. So which have so many laptops and desktops to be connected. They use switches. So most of the organizations, they use switches. So there are big boxes in the organizations and in our lab also, and there are wires coming out of it which are connected to all the desktops in our lab. So any connecting device can be used. It can be a router, it could be a switch, it could be a hub, it could be a modem. But what is network criteria? While you are designing a network, you are building a network, what are the main criteria to design a network, and what device to use? That is dependent on the multiple factors, and most of the three common factors are performance, reliability, and security. So performance can be measured in many ways, and the major performance parameters are transit time and response time. The transit time says when you are developing a network, how much time is required for the message to travel from one device to another. This is transit time. So if your data is traveling and it is taking a longer time to transmit from one device to another device, then the network is not of good performance. So you can change the network, you can change your devices, connecting devices, you may change the router, you change the hub, you may have a high performance switch. And the response time is the elapsed time between an inquiry and a response. So suppose I have sent my data to the server. I'm asking for, I'm doing some query. So if it is giving me larger response time, and if it is giving the result of the query after a long time, then the response time is more. So in that case, my network performance is not good. I have to redesign the network so that these issues of transit time and response time can be resolved. And we should have less transit time and less response time. And basically, the performance of the network depends on the transmission medium, capabilities of the connected hardware, and the efficiency of the software. Now, you must have seen various networks nowadays which are proliferated after this pandemic. So some people say Jio FiberNet is the best. It is the fastest one. Or maybe Vodafone in, V-in is best. Or maybe Airtel is the best. Or maybe some other service providers. So you are going by the performance of the network. So you may be having some network provider now and the performance is low. The transit time is low or the response time is low. In that case, you may change the network which is of high performance. So suppose if you are having Airtel FiberNet now and it is not giving you good speed and good transit time and good response time, you may switch to Jio FiberNet or maybe some other network which is giving you good performance. So performance is basically evaluated by the two metrics, throughput and delay. Throughput is the number of data, the amount of data which is basically communicated between the two parties. At a particular, suppose I say in 1 minute, how much data is transmitted. That is throughput. And delay. Suppose I say my data network is of high performance and it is 5G network. If I say 5G network, it is supposed to be faster than 3G and 4G. But if the throughput has increased and I'm using 5G, it may give me more delay. Like if you some of you are Jio users, Jio SIM users or Jio network users, you must have seen when you are trying to connect to a Jio user or you are calling from a Jio number. Sometimes it is busy. You are not able to connect. Though it is of high speed 5G, still you are not able to connect and you are getting delays in connection. Why? Because due to the throughput and the number of users who have increased, the traffic over the entire network, over their Jio cellular network and their whole backbone, that has increased. The total data which is flowing in the network has increased. Because the throughput has increased, the number of data transmitted between the parties is increasing. So the data which is flowing within the network has increased. And therefore the delay is created. So we often say that we want more throughput and less delay, but these two criteria are contradictory. So if we try to send more data to the network, we may increase the throughput, but we increase the delay because of traffic congestion in the network. So now we are saying our network is 5G, it should have less delay. But still we are getting delays because the traffic on the network has increased because of the throughput. So you may be having a high data speed, but the delay is increased. Got it? Students, are you there?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Then the reliability of the network. The network reliability should be maximum. Suppose you're buying a laptop or maybe a system or maybe some device at home. How do you purchase it? What criteria you consider while buying some mobile device or maybe a laptop or maybe a smart TV? The reliability. So you go to the company or you try to purchase a device which is more reliable, which has less chances of failure. So you go to the customer reviews when you are buying some product online or maybe some offline products. but you go to the website or maybe some websites which gives you customer reviews. So how many of the customers have used those devices, and what is the frequency of the failure? So you may be planning to purchase some smartphone which you think is very good, maybe some iPhone 10 or iPhone 11. But you are seeing its customer reviews. You see that some of the devices purchased by some of the customers, they are not up to the mark, or their reviews are not so positive. So you may drop the idea and you may go to a different model or different brand altogether. So that is a reliability is basically the frequency of failure. How frequently your device is failing. The same is same reliability factor is used for network also. While choosing a network and while designing a network, you should be able to have the high reliability of the network. So if you will have high reliability of the network and fails less, then the users will be interested in using your network. Then security. Network security issues include protecting data from unauthorized access, protecting data from damage and development, and implementing policies and procedures for recovery from breaches and data losses. Whenever you're installing some app, this is for networks though, but when you are talking of the networks, you should also be considering the security of the apps and your devices also. So network security, it includes the protecting the data and unauthorized access. So whenever you are suppose doing some online transaction, online banking, maybe you are doing some money transfer from one account to another, or you're paying some, or you're doing some online payment, you should always see the network security. How secure is your network, and how many people have unauthorized access to your network. So security is a major issue while designing a network or while implementing a network. Then physical structures. So there are two types of attributes depending on which you can decide what kind of a physical structure your network will have. Type of connection and the physical topology. First is type of connection. There can be a point-to-point connection. It can be a multi-point connection. Fine. So point-to-point connection, it has a dedicated link between two devices. Suppose I want to connect to you. I want to connect my desktop to you. I have a wire connected to my system, and I'll connect it to your system. That is point-to-point link. Point-to-point link is the simplest one, the best one, because you will not have any network issues. Suppose the link between my desktop and some other teacher's desktop is broken. Still, I am able to communicate with you. That is point-to-point. So every device connected on the network will have a dedicated link to other device. Suppose there are 5 devices or n devices in the system. So every device will be connected to every other device. So if there's 5 devices, how many links, dedicated links and dedicated wires I will be needing? Can anyone tell? Good afternoon, everyone.
Ma'am, can you repeat the question? Sorry.
Can you give me an example of point-to-point connection in which, sorry, can you tell me how many links, dedicated wires and links you will require for having point-to-point connection between 5 devices? Suppose I want to connect 5 laptops, 5 friends, and you don't want to communicate over a shared mechanism or shared media. So you will have a single wire coming out of a device, and that wire will be connected to your friend's device. So if you have your 5 friends, out of those 5 friends, you are the first one and you want to connect to other 4 friends. So you're needing 4 wires to connect to those 4 persons. Similarly, all those 4 friends will be needing 4 wires each to other 4 friends. So how many wires you'll be needing? How many connections you need?
Ma'am, in case of 5, there will be 25, and in case of 4, there will be 16, because each like one will require like individual wire to for in order to achieve the point-to-point connection, in order to not to share their data.
No, not 16 and 25. It is any to any.
Okay, ma'am. Okay, ma'am. Yes, ma'am. Yes, ma'am.
Because if out of 5 friends I am the first, I have to connect other 4 friends. So 4 wires to connect to 4 friends. Similarly, out of those 4 friends, one of them, if it wants to connect to all the remaining 4, that person will be needing 4 more wires. Similarly, all 5 of us, all 5 friends, will be needing 4 wires each to connect to the other 4 friends. So 5 times 4 is 20. That is
Yes,
n into
ma'am.
n minus 1. So if I am using a half duplex mode or simplex mode on the wire for data flow, then I'll be needing 40 to connect. If I'm using the full duplex, that means at a time if I'm connecting to one friend, I can communicate in full duplex mode with that friend. I can also communicate and she can also communicate at the same time. So I'll be needing only one link. But for communicating with between 5 parties, I'll be needing 20. Is it fine? Students.
Yes, ma'am.
So that is point-to-point connection when a dedicated link between the 2 devices is used. But the problem with can anyone see the difference? No, sorry, the disadvantage of point-to-point connection. What is the disadvantage? It is good. It is secured. Suppose I within 5 friends also, I don't want to share the information with the other 3. I just want to communicate my confidential information data with only one friend, not the other 3. So then in that case, I can send that information in the point-to-point link, because that will be only between me and that friend. So other 3 people will not know about my confidential data. Similarly, some other friend wants to send me the confidential data, then it can send it on the point-to-point link. So that way, point-to-point link is good. And suppose if my system is not working or my device is down, still if we have point-to-point communication, then all 4 of them can communicate amongst each other. Only my link with all those 4 will be closed, or it may not be working. So point-to-point communication, the entire network will not go down. Other devices will still be communicating if one device goes down. So a point-to-point connection provides a dedicated link between 2 devices. The entire capacity of the link is reserved for transmission between these 2 devices. Most point-to-point connections use an actual length of wire or cable to connect the 2 ends. But other options such as microwave or satellite links are also possible. So if you're using a cable, then the actual distance, physical distance between the 2 devices, that much length of cable is required. But if you are, you can use a point-to-point using microwave or satellite link also, but you have a dedicated link, and you can use the full capacity of that dedicated link in point-to-point connection. That's the advantage. Then multi-point is multi-drop connection, and it is a single connection between the multiple devices. So suppose from mainframe you will have a main cable and you have multiple taps, and all the devices are tapped into the same wire using the multi-point connection. Multi-point now in a multi-environment, the capacity of the channel is shared spatially or temporally. Spatially or temporally का मतलब है temporally in time. Suppose on this shared medium at one point of time this channel is transmitting or this device is transmitting. In another point t plus 1 this device will be transmitting the data on the shared link, and on this one this is the at point t is equal to 3 this device will be making. So you can use temporarily shared channel or spatially shared like you can have the space like on a particular band. Suppose bandwidth is of three frequencies. So the first frequency band will be used by the first device, second frequency band will be used by the second device, or suppose the frequency is 10 to 20 megahertz. So 10 to 15 will be used by the first one, or 10 to 30 megahertz will be used by the first device, 13 to 16 will be used by the another device, and 16, 19 will be used by the another one. So this is how you divide the capacity of the channel in a multi-point environment using spatially divided channels or temporally divided channels.
Ma'am,
हाँ
मैम सॉरी टू इंटरप्ट यू. क्लास हमारी 1:30 बजे से लैब की है, तो मे बी स्टूडेंट्स को चाहिए होगा टाइम.
I think this is a long one. Okay, we can stop here. Okay, so we'll meet at 1:30 again.